Okay, we're back talking more again about the weather, figuring out all the different systems and how they work. Talk about the different ways that storm systems form. I talked about forming in the mountains and forming through a convection. Those big hot summer days are going to be coming up soon, these huge thunderheads forming in the sky. A lot of it happens with they call cyclonic precipitation or frontal precipitation. Because remember how the difference between these low pressure systems, or warm air is rising, spinning around, basically creating kind of a vacuum effect. And the high pressure system, where everything's kind of, because of the Coriolis effect, spinning downward. But just a little added pressure on it. And of course, what's happening here is all this humidity and all these temperatures and everything are moving around. You've got these huge air masses moving back and forth. That's why we get in these different weather maps we see happening across the country. This is see, for example, here is with a cold front. Now the L, of course, representing low pressure system, and you'll see these long kind of lines of dark blue triangles on them. Meteorology, that represents a cold front. But it's centered on this low pressure system. Understand what's happening here is this low pressure system has an effect that could extend for hundreds of miles around it. And what it's doing is, here in the United States, would be, because the air is spinning counterclockwise as it kind of moves up, you're bringing in cold, dry air from Canada. But its effect isn't limited just here. It's also bringing in warm, moist air from the Gulf of Mexico. So creating on the other end sometimes, not always, but sometimes, a warm front. Some of these red semicircles. This is in motion, so it'll be kind of moving across the country over several days. Again, moving at the jet stream, moving generally west to east. Now we can see here more moist air moving against cold, dry air. As the seasons change, we move more into spring, summer. We'll see a lot of this pattern moving on. With a high pressure system, again, you'll have your map here. It's again just the opposite. Typically, kind of famous winter pattern we'll see. your big high pressure system, which we bring in cold, dry air from Canada, again spinning the opposite direction, creating these massive cold fronts moving down from Canada. What we often see after these cold fronts come through, you have may have several days that are very cold, but also very dry because that high pressure system. Again, often with these frontal boundaries, you'll see a lot of rain coming down. Rain or snow, mixed sleet, so forth. Example, West Texas, where it was in the 80s a couple days ago, there's snow today. Why? Because a very intense cold front moved through. You understand it takes a lot of energy to drop that from temperatures in the 80s to 70s and 80s down into conditions where you're producing snow, but that's what happens. There's a lot of energy associated with these storms. It takes a lot of energy to have that kind of effect over hundreds of miles. Um, so why is that rain always moving ahead of a cold front? Especially in this area, you have this warm, moist air, and suddenly it's cold and dry behind it. Well, it's because you have this cold, dry air. It's this big mass. It's on the move, but basically, it's like a boundary here. It's why they call it a front. You ever notice on a really cold, freezing winter day where your windows start fogging up or start getting wet at the bottom of them? Sometimes, like it's next to a glass door, sometimes it might even be frozen, ice at the bottom of it. It's the same effect here. What you see here is cold, dry air moving. Well, all this warm, moist air here, that's the ground, it runs into it. It says cold, dry air, it's heavier, it's thicker. What happens to warm air when it meets cold air? It goes up. So this is what's happening here is this warm air is meeting this boundary and starts condensing, dew point and all that. But also as it rises, starts creating these storm clouds. That's where you get your severe weather from. That's why we tend to have these severe storms in springtime, because the air coming from the north is so much colder and so much drier than that warm Gulf air that's sweeping in from the Gulf of Mexico. So the weather just tends to be more volatile because of these frontal boundaries. Except warm, moist air, because it's got all that humidity in it, all that moisture in it, rises to a level where it starts condensing, but it's still moving upward because of its, the effect of the warm, moist air moving against this cold, dry front. Clouds form, they get big, water droplets form, gravity does the rest. Next thing, you have another feature of that here. Especially against warm fronts. You have the warm air moving against it. But you don't have quite the severe weather. So you have these frontal boundaries, but you'll also have what's called a dry line sometimes. Dry line is a sudden shift in humidity. You'll see this a lot in the plain states. These dry lines moving along here, just that shift in precipitation, shift in humidity, suddenly make it much more likely that it'll produce rain on one side of that dry line, but not much change in temperature. Source region. That's where these areas form. It can usually be over several days. A lot of these very powerful cold fronts in winter form up here in Canada, northern Canada, and they move down in the United States very quickly. So they're called, sometimes called by meteorologists, an Alberta clipper. Now, an air mass, remember, that's a region of air with a similar temperature and humidity. And the front, of course, being the leading edge of this air mass. You can see from our examples here how it works in real time. Okay. Come on. Yes, it is. Okay. Weather channel showing the radar for the area today. Basically, rain showers kind of moving in from East Texas and eastern Oklahoma here into Arkansas. But again, notice it's kind of, again, because of the Coriolis effect, moving this way. And it's basically going to be doing that most of the day today. And this is weather.com. High today, 46, where it was 2 days ago, it was in the 80s. And yes, the National Weather Service has put us under a river flood. I go to weather.gov, you see all the different weather alerts for today. High wind warnings here in the plains. As well as here in Iowa and Wisconsin. And yes, in Texas and Oklahoma, far west Texas, and around the Amarillo and Lubbock area, winter weather advisory. Because temperature shifted that quickly. A lot of high winds and everything in Nevada today. We've also got some winter storm warnings up in the mountains. Look at the forecast map. And this one here, this is in weather.gov. Well, from 7 a.m. Eastern Time this morning until 7 a.m. Tomorrow morning. So you can see that's happening. This big cold front came through. It's low pressure system. It's it brought a lot of cold air down from Canada. But behind it, still got enough fairly warm Gulf air that's able to kick up all this moisture back up behind it into our area, where it just gets cloudy and starts raining. And back here, Wichita Falls back to Amarillo, Lubbock, and into portions of air towards Albuquerque, It's cold enough that it's got this mixed, you have this mix of rain and sleet, freezing rain and slush, just a messy day out there. But again, notice these high pressure systems here. They're bringing all this cold air again down from further north in here. Again, this hatched line here, dry line. So with that, dry air coming in behind it, and this wet air, this air coming in behind this low pressure system here in Canada, it's bringing warm air here to form front into the Dakotas, and bringing cold air in behind it from Canada, but also all this wet ocean air coming in across into the mountains in front of that frontal boundary, and around that frontal boundary. And that's how it works. So why is it snowing in New York and Ontario? Because of this high pressure system. Lake effect snows. And that's when you put it all together. So it all, comes down to humidity, air pressure, temperature, and all it's turning around. And yes, you can see how it all comes together here. Temperature side of it, very cool out here today. But a lot warmer out here, much colder up here. Got a short range forecast. Again, basically showing the same thing. That low pressure system has moved off from western Canada to central Canada. Again, spinning around, bring that warm air in front of it, and the cold, dry air behind it. At this point, this low pressure system came through a couple days before and basically becomes stationary. That's these alternating ones mean. Basically, nothing's kind of moving back or forth. It's just kind of drift off here to the east. These isobars showing changes in pressure systems. So then around this area here goes from 996 up to 1,004 isobars, millimeters of mercury. Means it's going to be a very windy day in Canada. So the differences in air differences. But it's also because of low pressure system again, it's going to be a very wet day in the east. That's what meteorologists study. That's what affects how you dress, what activities you got planned for the day, even whether construction workers can work or not. All that being affected by just all these weather systems working together. And remember again, this is National Weather Service. It's weather.gov. This is a global system at work. Has highly localized effects, and sometimes very highly localized incidents can affect local weather, but it's part of systems churning all over the world. For example, go back to National Hurricane Center. So much of these storms are going to start happening this summer are from ocean currents, particularly the Gulf Stream. You got this warm current of warm water moving steadily north and back up to the northeast. What's happening to that warm water as it moves along? It evaporates. Just natural. Natural process of evaporation. See, or the air around it gets very humid, sometimes releasing storms. And yes, these ocean currents, they can help carry and direct these weather systems because of the differences in temperature and the humidity. It's why England and Ireland, at the end of the Gulf Stream, why they're so notorious for rain. Because what happens? that finally spins up to the top towards Ireland and England with the Gulf Stream stops. Air is cooler. That warm air is that humid air starts condensing into rain, all coming from weather patterns thousands of miles away. And yes, so I'd say the Central Pacific. They've heard what's called the El Nino effect. Sometimes the water around the equator gets a lot warmer than usual, which means more moisture is kicked up in the air. That kind of affects the usual weather patterns. What happens? That weather forming thousands of miles away, the warmer than usual El Nino effect means a wet winter here in California and across here to Arkansas, from half a world away. These hurricanes that will form here getting off the coast of Africa, they will spin around, graze the coast of North America, and go all the way back towards England and Scotland. They will travel tens of thousands of miles. This storm system, this system has traveled thousands of miles already. It'll travel thousands of miles. Again, because it's meeting different weather systems, it will change over successive days. May go stronger, may grow weaker. In the case of the storm system, it'll grow weaker. Now, back to hurricanes. Now, a hurricane is an intense tropical cyclone. A hurricane is the name for these storms in the Atlantic and Eastern Pacific. But in the Western Pacific, they're called typhoons. Because you got nothing but thousands of miles of open ocean with very warm water. Those typhoons in the Western Pacific get much, much more powerful than do the Atlantic. Because while they're building up, there's nothing to slow it down. Here in the Atlantic, they have much of large islands and North America to run into to slow them down. So yes, you can get to storms out in the Western Pacific. They're much more powerful than they would be in the Atlantic. Again, just because of what they're running into. Once hurricanes hit land, they run out of that their source of warm, moist air is cut off. In the Indian Ocean and Southwest Pacific, particularly near Australia and New Zealand, they're called tropical cyclones. But they start off in the Atlantic as a series of storms off the coast of Africa. And as these storms end up growing, they end up starting to interact with each other, developing a low pressure system. And so when the first step, once this low pressure system forms, they're called a tropical depression. Now, because they're lower, because they're depressed, but no, because of the low pressure that's kind of low pressure that's sort of forming as these storms kind of coalesce into a larger storm. Now, just because you have warm air does not necessarily mean that you're going to develop a hurricane. Now, a lot of other conditions have to come into effect also. You can have a very wet, very warm, very high ocean temperatures, but that doesn't necessarily mean you're going to have a busy hurricane season. Well, the next step is it becomes a tropical storm. This is a low pressure system. It has sustained winds of 35 miles an hour, but on up to 74 miles per hour. Remember, it's sustained winds. It's not counting wind gusts. And it reaches hurricane strength when it hits 74 miles per hour. Now, most hurricanes are fairly small. Most of the Atlantic, most of them don't hit land, but some of them get very large, very intense. And by tradition, each of these systems, once it reaches a tropical storm, it gets its own name to kind of keep track of it. Makes identification easier for forecasters. Because sometimes, yeah, you can have two or three of these storms going on at one time. Just referring to the hurricane, that's not specific enough. You've got a hurricane out coming towards Cuba, possibly heading towards Florida. There's also another hurricane out in the Pacific Ocean. So what ends up happening, though, over time is as this low pressure system develops, all this rain and storms and everything forming around it, intense rain around it, basically it ends up developing what they call an eye. Big low pressure system in the middle of it. So basically everything's spinning around it. And you have this kind of centrifuge effect around it because it's kind of basically it's pulling everything around it. The lowest air pressure point is in the eye, but it's also where strangely enough, the weather's calm. And that's really kind of a freak thing. A lot of people notice this when hurricanes pass over is you have this intense storm for a while, then suddenly it stops. And people actually go outside and look and see, they can see it's actually kind of clear for a little bit, but see all the storm clouds in the distance. They know the eye is going to pass over very quickly, and you're going to have those same intense storms again. So these well-developed storms, they get this very noticeable eye in the middle of it. It's basically this little dot of clear weather. Like I said, the most intense storms, those names are usually retired. For example, Hurricane Katrina from 2005. It was a Category 3 storm when it hit, but it caused so much destruction and it was such an intense storm that they're not going to use the name again. Same thing with another hurricane hit the Mississippi Gulf Coast, 1969, Hurricane Camille. They're not going to use that name again. In fact, people live along the Gulf Coast or along the Atlantic coast. They'll talk about these storms and they'll refer to them by name. See, I remember Camille. Yeah, I remember Katrina.
I was in the coast when Katrina hit, so I was in the middle of all of it. We were trying to come down here to see my grandparents, and we were just smack dab in the middle of all of that.
Yeah, they have all these hurricane evacuation routes and everything to try to get people prepared and so forth. And the newspapers and TV stations, what they'll often do sometimes when hurricane season starts is they'll give these little maps of the Atlantic Ocean out to people, so they can track these storms as they move across the Atlantic, know when to board up and head out. Actually, sometimes it's because of where we are here in Arkansas. When a hurricane hits, say, Mississippi, Louisiana, or even Texas, because it's still moving northward, it'll actually hit Arkansas. But by the time it gets here, it's so weakened, it's usually down to just to a tropical storm again. But it means a lot of rain. These hurricanes, they can drop a couple feet of rain. Yeah, there was one hurricane that hit Houston a few years ago, and it stalled out over Houston for several days. And they had like 4 feet of rain. I had friends that were telling me they were basically getting from one part of town to another by boat and by raft. But as hurricanes start dying, they'll go back down to tropical storm status, then back to tropical depression status. And they still have some organization to them. Usually, once they're back down to tropical depression again, they'll basically be called post-tropical cyclone. Because again, you can still track the remnants of it again for thousands of miles. They move back east across the Atlantic. So it's kind of going in a big circle around the Atlantic coast. And yes, they go into categories. They developed a category system for tracking the strength of these different storms. Category 1, from 74 to 95 miles an hour. Category 2, from 96 to 100 miles an hour, or 110 miles an hour. Again, these are sustained winds, not counting gusts. And when these storms hit the coast, such volatile weather, they can produce a lot of tornadoes. And the most intense damage from hurricanes isn't the rain, though there is a lot of flooding associated with them. It's actually the wind. Because you're not just getting 100-mile-an-hour winds, you're getting gusts up to 120, 130 miles an hour, depending where you're at. That'll get your attention. 111 to 130 miles an hour. Of course, coastal communities, construction is designed in a way to help withstand the most intense effects of a storm. Chain link fences, what they call up here in Texas, down the coast they're called hurricane fences because the gaps in the chains allow wind to go through. 131, 155 miles an hour. 45, 155 plus. Rarely do they get this big, but sometimes they do. And so the size of these hurricanes, like I said, they can extend for hundreds of miles and affect weather for thousands of miles out. Storm can be developing in the Gulf of Mexico, middle of the Gulf of Mexico, and you already see clouds coming into Arkansas because of how it's affecting the weather systems. And on into the 1970s, early 1980s, they really weren't sure how hurricanes moved. So it's very hard for them to predict where are they going to go. Because sometimes they'd suddenly shift directions back and forth. They didn't know why. But as we did more studies on the atmosphere and how all these different high-pressure systems, the jet streams affect them, particularly we've got a better system of radar and satellite coverage of the oceans, we can start better predicting what was going to happen with them. So for a couple days beforehand, they'll have hurricane watches all along the Gulf Coast, but then they'll start to, and they'll have hurricane warnings for particular areas they know are more likely to be hit. As the hurricane forms gets closer to land, they'll start narrowing down that hurricane watch and hurricane warning area, so they'll predict it. Because, for example, it might have a high pressure system, the upper level of the atmosphere, or a low pressure system, which could be, those upper level winds could be pushing a hurricane one direction or keeping it from going a particular direction. They keep it further south or help it go further north. As they're able to study those winds a lot more closely, they're able to help predict hurricane direction a lot more carefully. The Atlantic hurricane season, it usually starts in June, but there have been hurricanes as early as March. where it usually ends at the end of October or even November, there have been hurricanes on New Year's Day sometimes. Just these weird little freak things come up. It was especially dangerous back before they had all these tracking systems. They'd be sitting along, and all of a sudden they have a hurricane coming along them. They know it's just a couple days out. They have no idea where it came from, but it's because they couldn't track deep into the oceans yet. They didn't have 1920s and 1930s. They didn't have satellite forecasting. They didn't have weather radar yet. So it could be really dangerous that time of year because suddenly a hurricane come up, you had no idea what was happening. It's because of those low pressure systems, it's having just a little bit of a vacuum effect. Not an intense one, but just enough where it's really kind of churning up the oceans, and the waves get a little higher than usual. The ocean gets a little higher than usual. That's a big problem with hurricanes too, is what they call the storm surge, where your waves coming in and the ocean is suddenly just several feet above normal because of this low pressure system, everything being stirred around in the ocean. So that's hurricanes. Blizzards. It is a very intense snowstorm. What they usually associate though with is heavy snow, high winds, and bitter cold. Not just a little bit of snow, but it's like a thunderstorm, but with snow instead. But rarely are there's a lot of thunder or lightning with the snowstorm. Sometimes they have that. They call it thunder snow, but it's very rare, or comparatively rare, we should say. But blizzards, yeah, these intense snowstorms, they can dump a couple feet of snow in some areas. And the danger is in these areas what's called a whiteout. Whiteout basically where there's such intense snow, it's flying in so many directions that visibility is cut down to zero. Even though it's bright outside, but all you see though is snow. And you just can't really see much further past your hand in front of your face. And that's a real dangerous situation, especially when you're driving in the middle of that, or you're outside all of a sudden, you're in the middle of a blizzard, there's whiteout conditions. There have been situations where people just wander a few feet from their house and they get lost in the whiteout and can't find the way back and freeze to death. So every area has its own a particular storm danger. Tornadoes. It's a Spanish word. And the Spanish came to the Southwest. They noticed these storms appearing every so often. They really didn't have those in Europe. They do. A tornado in Europe is very rare. The United States, because of the general volatility of our weather systems, this kind of geography, everything, we're much more prone to having tornadoes in other parts of the world. Doesn't mean they don't have in other parts of the world. It just means it's more common around here. In particular, the area from North Texas out up into Oklahoma and into the Dakotas, and even out here into Arkansas and Missouri, that's an area called Tornado Alley, because that's the areas the most intense tornado activity happens. Tornadoes can and have been reported in all 50 states, but they're most common in the area we live, from portions of Arkansas back to the Texas Panhandle and up to the Dakotas. But even that area, there are areas that have much more prone to tornadoes, particularly Oklahoma and Kansas. There's one little town near Oklahoma City. They just get hit by huge tornadoes every couple of years. Just bad luck. Now, again, they can happen any time of year, but most common in spring or fall, again, with all these intense storms coming through. And here's basically what happens is This cold air comes through. And as it comes through sometimes, sometimes a little pocket of warm air is trapped inside of it, under the bottom of it. Physics means that warm air wants to move up. So it starts moving up, though, but it does some spirals. Most tornadoes don't reach the ground, usually forming within clouds, but they can be very intense. And caused by warm air surface at near the surface, the storm suddenly rising very rapidly. It's rising through a layer of cold air. Because remember, as it's rising upward, spinning, it's going to spin very rapidly. Like I said, very powerful, very highly localized, very intense storms. But again, most of them don't touch the ground. Most of them are actually fairly weak, but they can strengthen very rapidly. The thing about tornadoes is sometimes they're very unpredictable. They can suddenly get very strong very rapidly, then weaken very rapidly, and reform again. Several tornadoes can form the same storm, sometimes combining into a larger, more powerful one. They can exist and go on for a few feet and then die out, or they can go on for miles. 1925, there was a tornado called the Tri-State Tornado. It started in eastern Missouri, crossed the Mississippi River, moved across southern Illinois, before finally dying out in southwestern Indiana. Hundreds of people died. In the 1920s, they didn't have storm warning systems. The most dangerous were always at night because you didn't know when these severe storms were coming up, and you didn't know, and there was no way of warning anyone as a tornado was coming. Today, because of modern forecasting techniques, because of Doppler radar and computer imaging systems, we can actually pinpoint very closely where a tornado might form. So we can generally have up to, at this point, up to about 5 minutes warning that a tornado is about to form, and generally be able to track it, get an idea of where it's going to go. So we can warn emergency services, we can sound the warning sirens and alert people that a tornado is coming, allowing them to take shelter. With that, these warnings have saved a lot of lives. But like I said, they do really bizarre things. Sometimes, again, because of the volatility of them, you may have entire houses smashed, but the house right next to one that's destroyed is left completely alone. Like it'll suddenly tornado just lift up and just skip a couple of houses and then come down again to the next one. Tornadoes can have winds as strong as 300 miles per hour. It's pretty strong. Very strong, very intense winds. Yeah, it can do a lot of things. It can actually lift train cars up. It can blow cars around like they were little matchbox cars. People note that sometimes they can drive a piece of straw, a little piece of hay, into a tree like a spear. I remember when things start moving at 300 miles an hour, they can start doing weird things. And that's the intense damage from it. I mean, got a 2x4, okay, sling that at 300 miles an hour. What happens? It comes through a center block wall. That's what happens. You get to throw something like a 2x4 with enough force. And 300 miles an hour, that's a lot of force. They sometimes houses explode, so you should rush to open your windows.
No, you shouldn't do that because as tornadoes approach, a lot of debris is flying and it can smash your windows. And that effect where the pressure gets so low, houses explode. Basically, for the pressure to get low means your house is directly in a tornado. And opening the windows isn't going to fix it. What might happen is those winds might blow your roof off, where your house otherwise might have been fairly safe. Like I say, so if a tornado is coming, don't try to open windows. Just get to someplace safe. That is basically into a bathroom on the lowest floor. Remember, it was about 20 years ago, tornadoes coming through El Dorado, and they had everybody here in this building get down into the basement area and the very bottom of the building while they waited for the storm to pass. Fortunately, nothing major happened, no damage, no one hurt. But they had to kind of scramble very quick to get everyone in this into the basement. That's why a lot of areas, like you see out in the countryside, you'll see this this little concrete lump out in the middle of people's yards, sometimes near their houses. Those are storm shelters. So people are going to run into those someplace that's fortified and safe and fairly underground so they can ride out a tornado. Some houses have storm cellars, but in Arkansas and Texas, Louisiana, we really don't have a lot of basements because the ground's usually just too hard. But to measure the strength of a tornado, they developed something called the Enhanced Fujita Scale. A scientist named Fujita, he developed the scale to measure the strength of tornadoes. And you see those people chasing storms, I'd recommend against that because those things can shift direction very quickly. And it's not just the tornado you're worried about, but also all the hail storms and everything around it. Straight line winds can cause a lot of damage themselves, not just the gust in a storm, not the swirling tornado effect. And it starts with the F0, and that's up to 72 miles per hour. That's most tornadoes. Again, very small, not much effect. Sometimes not even reaching the ground. And sometimes to determine just how strong these were, they have to look at damage on the ground. See just kind of how strong it was. Because sometimes the tornadoes, these strong ones, when they hit the ground, they will leave trails for several miles. But the F0 and F1, that's a good portion of them. The F4 and the F5, that's about 1% tornadoes. So any of them need to be taken seriously, but the F5, that's the upper end of the scale. That's 270 to 300 miles an hour. The ones that cause that catastrophic damage. And these tornadoes, they can be very narrow. They can be several miles wide. Actually, they can be very powerful. There's been a couple of cases in recorded history of tornadoes crossing the Mississippi River, and storms were so strong and so wide that they parted the waters. The Mississippi waters just parted because of these tornadoes. They're very impressive, but you got to take them seriously. Is ocean currents, page 4.3, and of course, cloud types. Cloud types tell us a lot. This is figure 420 of the book. Now, the most famous, most common ones you see are the cumulus clouds. those small, puffy kind of cotton clouds. The ones that have all the kind of neat little shapes in them. These are generally the lower troposphere. But as they kind of build up over time, and you can see them actually kind of on a warm day, springtime and summer, see them kind of building up in the sky a little bit, getting bigger and growing. They grow and they can combine and into what they call a nimbocumulus. That's what this is. These are big thunderhead clouds. Stratus clouds is generally low-lying clouds, usually kind of gray. Usually water, sometimes ice. A kind of an overcast day, that's basically stratus clouds. A nimbostratus cloud, that's also a rain-producing cloud, but it's not as tall or as intense as a nimbocumulus. Sometimes you'll have this really kind of a weird effect, we call it a lenticular cloud. And because it's a rare form of cumulus cloud where the edges are kind of shaped by surrounding winds. So they don't look like these big puffy cotton balls or anything. They look like they actually kind of lens shaped, kind of round, kind of weird looking. Some people have actually mistaken them for UFOs in the past. Just because of weird wind effects, but no, those are just regular clouds. Gotta remember, weather can do a lot of weird things. Right conditions in the right place at the right time. Any type of rain-producing cloud is called a nimbus cloud. It's the prefix nimbocumulus or nimbostratus. And even up at the in the upper stratosphere, the upper troposphere, have what they call cirrus clouds. These kind of thin little wispy clouds. A lot of times those are formed by ice crystals. They're so high up. No liquid water, but you have plenty of ice moisture just forming into ice crystals. Sometimes in winter time, in especially more northern latitudes, sometimes at night you'll see the moon, but you'll see this big, this kind of ring kind of around it. What's happening is because the moonlight is basically it's illuminating ice crystals in the upper atmosphere. Usually indicates that snow will happen within a couple of days. And yeah, these nimbocumulus clouds, they grow because of sunlight, because of all that warm, because that warm air caused by sunlight. In fact, even as they cross over this horizon, even at night sometimes, where it's kind of dusk and kind of dark on the ground where we're at, we look further west, we see these very bright white nimbocumulus clouds. It's because they're so high up, the sun's still shining where they're at. Even though the sun's already set on the surface. And yeah, sometimes full moon at night, a lot of some cloud cover that, the moon will illuminate clouds at night sometimes shining through them a bit. You also got something called notilucid clouds. Notilucid clouds. These clouds are generally up to 14 to 17 miles above the surface. Sometimes it might have a brownish or orangish tint. Kind of white, maybe a little bit of orange or brown on the edge of it. Very high up, 14, 17 miles off, made of ice crystals. But one thing it's also made of has a kind of orange or brownish tint. Meteor dust. That is the weather. So something you gotta know about and you gotta be aware of, especially in this area, because weather changes so rapidly and so constantly. Like all saying here in Arkansas, if you don't like the weather, wait a few minutes, it'll change, because it will. Right. That's it for now.